He might have predicted this, but here's the twist. Nature may have beaten his art to it. In the 1910s, when Kazimir Malevich painted his haunting black square, he couldn't have imagined what awaited us out there in the cosmos. Fast forward a century, astronomers began mapping the vast, silent spaces between galaxy clusters, the great voids of the universe. But nothing could have prepared humanity for what Robert Kirshner's team stumbled upon in 1980, an enormous spherical gap in the fabric of the cosmos. They called it Boötes Void, or more dramatically, the Himalayan Void. It stretches a staggering 330 million light-years across, a cosmic chasm so immense that galaxies within it are few and far between. To put that in perspective, if our Milky Way were floating in its center, we might still be in the Dark Ages, unaware that other galaxies even existed. Back in 1920, we discovered the first hints of galaxies beyond our own. Had we been inside Boötes Void, that realization might have come far later, or perhaps not at all. Imagine it. Our entire galaxy, with its 300 billion stars, reduced to a speck of dust in a dark, infinite gulf. That's Boötes Void, the emptiest known region in the observable universe. You'd expect such vastness to be brimming with galaxies, yet scientists have found only about 60. By comparison, our local group alone has 24 within just 3 million light-years. In a space this large, we should see around 10,000 galaxies. Instead, near total nothingness. A haunting cosmic silence. Picture yourself there, adrift in the middle of Boötes Void. Around you, endless black. No starlight, no galaxies, no cosmic landmarks. Photons and neutrinos drift lazily, untouched for hundreds of millions of years. A time capsule frozen in the void. It's the ultimate isolation. But just when you think space can't get any stranger, it does. Because Boötes Void has competition. We're about to enter the coldest region in the known universe. In 2004, astronomers detected an eerie chill emanating from the constellation Eridanus. If you could imagine an icy hell, this might be its home. The cold was traced through the faint relic glow of the cosmic microwave background, the afterglow of the Big Bang itself. The radiation passing through that region seemed to lose energy, as if drained by an enormous, invisible emptiness. Meet the Eridanus Supervoid. It spans an incredible 490 million light-years across, and possibly up to 2 billion. If confirmed, it would be the largest known structure in the universe. This frigid gap cools the ancient radiation by about 20 microkelvins, and the central cold spot dips another 70 microkelvins below its surroundings. Why? That's the mystery. Some scientists from Durham University propose that what we're seeing isn't one giant hole, but a network of smaller voids, like bubbles in cosmic foam, where galaxies cling to the thin walls between them. Others, like astronomer Tom Shanks, dare to go further, suggesting something truly mind-bending. What if that cold spot marks a collision between our universe and another? If true, this could be the first evidence of a multiverse. Countless universes existing side by side, occasionally brushing against one another and leaving scars on the cosmic background. It would shatter our understanding of the cosmos and of the Big Bang itself. You see, according to the traditional model, matter after the Big Bang was evenly distributed. But these giant voids break that rule. They suggest something else, that our universe might be older, stranger, and more dynamic than we ever imagined. Some researchers think these voids formed not from ordinary matter, the stuff of stars and planets, but from the early movements of dark matter long before galaxies took shape. Over time, smaller voids may have merged into the vast hollows we see today, pushing galaxies into dense walls and clusters, leaving behind sprawling cosmic deserts. And that brings us home, literally. In 2013, astronomers made a jaw-dropping discovery. Our Milky Way itself sits inside a massive underdense region, a void roughly 2 billion light-years wide. They called it the KBC Void, named after Ryan Keenan, Amy Barger, and Lennox Cowie, the scientists who found it. They described our place in the cosmos as the universal outback. This could explain one of cosmology's biggest puzzles, the conflicting measurements of the Hubble constant, the rate at which the universe is expanding. If we're living in a region with fewer galaxies and less matter than average, the light from distant galaxies would appear slightly different, throwing off our expansion calculations. In other words, our cosmic address might be skewing our view of the universe itself. And that realization changes everything. Because if true, it means that our understanding of the cosmos, its size, its age, even its expansion, might depend entirely on where we stand within it. So here we are, in a small spiral galaxy, floating inside a vast bubble of emptiness, on the edge of an infinite mystery. The deeper we look, the more the universe reminds us, we are not the center of it. We're part of something far larger and far emptier than we ever dared to dream.